Okay, I think we could get started. Can you guys hear me?
Yes.
Cool. So as you all should know, this is Introductory Algebra for late middle school or early high school. Okay. So this is the course, uh, Introductory Algebra. So for a few notes before we get into this, so this is for your benefit, not mine. So it'd be nice for you guys. How should I say? And I hope you learned something here, from this course, and I hope it's interesting and fun for you all. So if you have any questions or suggestions, since I'm new to this as well, you can always email me or use the Discord. Each class will be recorded, so if you miss anything, you can always review it. And whoever came in just now, already started a bit, but you could review with the recording later. So many of us are probably at different math levels. Some of us might be going forward or might be just reviewing for their own classes. And while I can't really skip any lessons since someone might get left behind, I could give those more experienced harder things if you would ask for it, just so nobody's bored. And feel free to ask questions in the Zoom chat. So I will be using Socratic in this course to ask questions. And so if you were to log on to this room code right here, I would appreciate it. And while I can't force you to participate, it would help all of us. And does anyone have any questions about the course in general? So whoever just came in, we've just gone over the course, but you could review that in the recording. But feel free to ask any questions. So we will begin with the types of numbers we have, because numbers are a fundamental part of math and thus algebra. So these numbers, the blue as indicated, are positive integers. They're whole numbers. You can count them with whole things like 2 apples, 1 apple, 3 cookies, 4 cars. And we also have 0, which is when you say 0 or something, you mean you have nothing of that. Like, I have no cookies. The negative numbers are the negative integers, I should say, are the positive integers, but minus that. Like, a good example here would be, I took out a loan and spent the money, so I now have negative money. And so the relation between negative and positive is that a negative integer plus its positive counterpart, like 2 here, will equal 0. And on the other hand, the negative of a negative integer will equal its positive counterpart. The other types of numbers we have are, negative numbers would mean I'm in debt or that I have to pay off money. So the other types of numbers we have are rational numbers, which are part of something. So like, if I had, say, a whole pizza here, and I were to eat this quarter of it, I would have 3/4 left. That's a rational number. Once we get more into detail about this kind of thing, a rational number can be expressed in a ratio of an integer, like 3/4 can be expressed as the ratio of 3 to 4, 0.333 infinity onwards is 1, 2, 3, and this symbol means that the number below it is, the digit below it is repeated. So like this mark on the number line is 7.5 or 15/2. And these rational numbers can be negative or positive. Also, the integers are also part of this group. So 6 can be said to be 6/1. Am I going too fast? On the other hand, there's irrational numbers which cannot be expressed by an ratio of integers. We will talk more about this later. So we have the integers in this category, integers which also have positive integers in them. These are the integer characters. For the question, pi is irrational. It cannot be expressed in ratio of integers. And then we have the bigger group here, which is rational. And then we have another group here, irrational numbers, which I will talk about later today, actually. And we have a very large group size, which is real, which is most numbers. And there's something else there's something we'll go over in later lessons, but there's complex or imaginary numbers, which we don't have to consider for now. So now that we've got that down, we have to set down the laws of arithmetic, the way you use numbers. So we have to go of the order of a lot. Actually, I will ask a question in the Socratic first. What type of number is 1.3? And the chart beforehand. So like integer, is it an integer? Is it rational? Is it irrational? And I'll ask in the Socratic.
What's Socratic?
Oh, it's a website. So if you Google it, and I'll show actually. So if you Google it, and you go into student login, so my room name will be Algebra 5775, and you can answer my questions there when I ask them.
I just used the chat privately.
That's fine as well. Moving on, you could answer the question on your own time, but order of operations. So let's say we had something like this. So
I couldn't find the page.
Sorry, what?
I couldn't find the page.
Oh, so my room code's Algebra 5775.
That's easy.
So if you had an expression like 5 minus 3 plus 3 times 5 divided by 2, for example. So you would go in order of operations, which is parentheses. Exponents, which we will talk about later.
I couldn't find the page. I couldn't find the page.
I put the
PEMDAS.
yeah.
PEMDAS.
So I put the Socratic link in chat. So you should be able to use it there.
When I type it in, it says invalid room. When I type my room thing in, everything is in Spanish. Then like there's a little English at the bottom and you can choose your language. See? There's a Spaniel too. I can't see. You can't see? There's a little. It doesn't say that.
Could you mute yourself? Okay, so exponents, multiplication, and division, which is actually, so the orders here, these are on the same level actually.
I made the things English, but it's still in Spanish.
I didn't write anything in the Socratic, you could just answer it. Which is left to right. So it's parentheses, exponents, multiplication, and division in a left to right order, and then addition and subtraction on also a left to right order. So now that we've gone over that, what does this expression simple down to? Parentheses 5 minus 3 plus 3 times 5 over 2.
When I enter Socratic, it just show me one of questions.
Yeah, that's fine. Just answer your question there.
It says invalid room when I type algebra 5775 in the Socratic.
Do you capitalize it?
Yes.
Yeah.
When I...
Oh, now there it is. Okay, now I could do it.
It works on my end.
I didn't have spaces. I'll just do it privately in the chat.
Yeah, that's fine. If it's not working for you, you can always use Zoom chat.
I already submitted answer.
Yeah, whoever submitted it's correct. That's also correct. Whoever submitted, it's anonymous, so
Oh, okay.
whoever submitted just now, please simplify your answer again. Okay, so moving on. So we also have to talk about commutative and associative properties. So when I have, say, 5 of something, like say 5 bananas, and I have, actually when I get 5 bananas, and then if I get another 3 bananas, it will be equivalent to if I get 3 bananas plus 5 more bananas. This is called the commutative property of addition. Commutative of addition. And on the other hand, if I were to say have 5 bananas and then suddenly lose 3, would it be equal to having 3 then losing 5 per se?
No, that's not even possible. That you have -2 bananas.
say we had dollars instead of bananas, but yes, these two aren't equal. So subtraction is not commutative. But if I were to have 5, if I would have 5 times 3 rectangle, say I have 5 plots in the row and 3 rows, it would be the same as having 3 in a row and 5 columns. So multiplication is so commutative. On the other hand, if I would do this, just like subtraction, these obviously aren't the same. Yeah. For associative properties, if we have 5 plus parentheses 2 plus 6, it'll be, and we have this as well, they're just different things in parentheses. This will be 7, 6, 8, 5, and both be 13. This is the associative property of addition. By the same mark, 5 times 2 times 6 would be equal to 5 times 2 times 6. However, if we had 5 divided by 2 divided by 6 and 5 divided by 2 divided by 6, is this equal? No. If you were to use PEMDAS on this, this equals 1/3, this equals 5/2, and 5/2 divided by 6 is 5/12. While on the other hand, 5 divided by 1/3 equals 15. So division is not associative. There's a similar process with subtraction. These two equations are not equal. -4, 9, this equals -3. Subtraction is not associative either. So now we move on to the next. So distribution and factoring. So let's say Bob has $9 and Joe has 15. How many, if say a pair of shoes costs $6, how many shoes can they buy? Just answer in Socratic. And also another question is if a jar contains 3 cookies and
Okay, I couldn't see the question though.
oh, so if
Also,
I can type it in chat. But usually I don't put in the question into Socrative, I just say it. So if a jar has 3 cookies and there's a box of 5 jars and a box of 2, how many cookies are there? Well, I mean collectively speaking, how many can they buy together? Slightly more. So this is distribution and factoring. And so, by answering this question, you've answered 9 plus 15 over 6. This is factoring out a 6. And this is if each jar has 3 cookies, then in total there are 5 jars. So 5 plus 2, 3 equals 21. Yeah. No. So how about another, to get more into this factoring? So a budget is split into, say, apples and bananas. If there are $32 in this budget, so they have $32 to buy bananas and 24 to buy apples. If apples costed 1.25, actually $1.5, and bananas costed, say, $2, how much food can they buy? So we need to find the total amount of food And thus, we need to find how many apples and bananas they each buy. So we have to do this. But what if these weren't whole numbers, but say, what if these weren't apples or bananas we were buying, but instead more abstract things, such as say types of pizzas where you could fraction it. So 33 over 5. So $33 for pineapple pizzas that cost $5 each, with 17 over 4. $17 for $4 pepperoni pizzas. Here we can't leave these fractions like this. It's messy and it's just not one number. So what we could do is we need to find the lowest common multiplier of the denominator, the bottom part of the fraction. In this case would be 20. And 33 gets multiplied by this this lowest common denominator divided by its denominator, which in case 5, and 17 gets times by 20 over 4. This eventually sums out to be 217 over 20. Yeah, I write x as asterisk because we will be using x as a variable later on. Dots are rather small, and you might not see one. So now we get onto equations, which a nice metaphor for is a scale because they're equal. So 1 plus 3 equals 4, 5 times 7 equals 35. So when you have two equations together, like say I have here, so 1 plus 3 equals 4, 5 plus times 7 equals 35. I could add these two equations together because each side is the same. 1 plus 3 plus 5 times 7 equals 4 plus 35. If you check both sides equal 35, the same thing can be done for multiplying. So 1 plus 3 times 5 times 7 equals 4 times 35. The same with divide. If I were to draw a divide here, divide, so each side equals 4 over 35. Also 1 plus 3 minus 5 times 7 equals 4 minus 35. So clearly you could see that you could combine equations to get another equation that may or may not be more helpful. Another thing about equations is if I say had numbers like this 18 times 72 equals that equals 1296 without looking at anything. And then I said 24 times 54 also equals 1296. Is this, and I had a third equation that may or may not be true, but if these both are true, check, then this last equation is obviously must be true since 18 times 72 equals 1296, which also equals 24 times 54. This is what they call the transitive property, I believe. The transitive property of equality. Oh, the mental math. Where I use 9 times 144, which is a shortcut since you could do 140 minus 144, but that's less relevant. Now on to more interesting things, which are exponents. My Google slide for it. So exponents. So how I would describe exponents, which is 5 plus. So multiplication essentially is adding the same number over and over again. So let's say if we had 7 5s here, that equals 5 times 7. Exponentiating is the same thing. So 5 to the power of 7 is what we would say is 5 times 5, etc., 5. And there's 7 5s. So as a quick question, so exponentials are really what makes bank interest add up per se. So if Bob opened a bank account with $50 with 2% interest each year, that would mean his money is being exponentiated. So each year, his money gets multiplied by 1.02. So after the first year, 1.02, second 1.02 squared, then cubed, then fourth. And you can see how this kind of stacks up. For a quick exercise, and you could use a calculator for this, either online. I don't particularly mind you guys using calculators, just don't rely on it. Like 50 times 1.02, 90.
What? What was the question?
So what's 50 times 1.02 to the 90th power? Yeah. Yeah, and if you after you calculate it, you can see how big this number is. I don't really need you guys to submit it, but it just goes to show how powerful interest and exponentiating is. Another thing we need to talk about exponentiating is, well, multiplying them together. So let's say we had 5 times 3 and 5 times 7. So this equals 5 times 5, 3, and this is the same thing, except there's 7 5s instead. So since these are multiplied together, we have 10 5s being multiplied together. So that equals 5/10, which is a good loss to remember. So if we had a number a to the b power times a to the c power, this equals a b plus c. So exponentiate x powers 1 multiplied add together. Awesome. And also for a quick mind, so what's 10 to the 0th place? I've already showed positive numbers power. So what's 10 to the 0th place? Yeah, good. It's 1. Try not to spam the chat, but it's fine. So since there's nothing really being multiplied, everything just becomes 1. Another good way to think about it is using this law. If b were to be 0, times ac equals a 0 plus c. So this just cancels out, becomes c. So a0 times ac equals ac. So a0 must obviously be 1. If we were to divide exponents, so a b over a c, or let's say, for example, 5 6 over 3, no, 5 cubed, which is the shorthand for to the 3rd power, equals 5 to the what power?
5 to the 3rd power.
Yes, it is to the 3rd power. So we have, so this law is equal to a b minus c. now that we've gone over exponents to a positive power and to the 0th power, what do you think 5 minus 2 means? Remember that 5/2 can be said as, if I were to use 5/0 over 5 square, this would mean that this would equal 1 over 25, or 5 minus 2. Another part of exponentiating we need to talk about is exponentiating by rational numbers. So if we have 10 to the half, this 10 to the half, this would
be square root 10.
That's square root 10, which is a radical. This also follows for 10 1/3. Basically, what this number means here is that if you were to times square root 10 by square root 10, it would equal 10. And so when we talk about radicals, we should really talk about irrational numbers, because these radicals most of the time, or actually all the time really, would be irrational. So what an irrational number means is that it cannot be expressed as a ratio of 2 integers. So rational numbers say 1.37 can be expressed as 137 over 100. Have a square root 2 cannot be expressed as such. And if you try to say, and this was actually made up by a Greek mathematician named Hippopotamus, which was highly controversial at the time. So if we would try to have such integers where p and q are integers, if we were to multiply this by itself, you could show it to yourself that it's impossible to have p and q such that their squares would have a ratio of 2. Now, if we had, let's say, 10 to the half, and then let's say we had 15 to the half. If we squared these two together, we would get 2 half squared times 15 half squared equals 150. Thus, 10 half times 15 half equals 150 half. Or to use the radical denotation, square root 10 times square root 15 equals square root 150. So square root A times square root B equals square root AB. Now, if we say had a number such as 4, square root 4 here, and we square rooted it, it would be 2, which is a rational number, and it loses the radical. But what if we had, say, square root 4 times 13? This is an irrational number. However, we could simplify it, since this equals square root 4 times square root 13 by our law before. This can also equal 2 square root 13. And as an exercise, you could do, say, 17 plus square root 52. These are both. You could add these two together, since they both have a divisor of 13. So this will be equal to 3 square root 13 plus 2 square root 13 equals 5 square root 13. For real life purpose per se, so if you know some geometry, you would know that for a triangle CBA, a square plus b square equals c square, which is exponents. If, say, c were 5 and b was 2, a square equals 25 plus a square plus 4 equals 25, and a square would equal 21, which would mean that it's a equals square root 21. This is the Pythagorean theorem, by the way. In answer to another question, square root 4 is not negative 2. If you were say to have this equation, a could equal negative 2 or 2, have a radical force strictly positive. And that's it for today's lesson, actually. If anyone would like to stick around and ask anything, I'd be happy to stick and answer. But if you don't have anything, you could leave.